Hi everybody, and welcome to the homework video. In this video, I'm going to do your homework for you. So here we are in Canvas, no not Canvas, in Hawks. This is my Hawks page, this is my calculator, and I'm going to do most of my work, practically all of it, using the calculator. And notice we have our three sections. We have our Learn section, which is kind of like their version of my lecture. We have Practice, where we can practice, and then we have Certify, where you actually do your homework. Now notice here you only have to get a mastery of 71%, which means that you need to get 5 of the 7 problems correct. And if you do, you are good to go. And if not, you're going to have to do it again. As usual, I am going to go and do this in practice. So here we go. And this is our first problem. Now this is a very silly question, which is in our homework. I wish I had the authority to take it out, but I don't. And here they want you to come up with the best point estimate for for the mean monthly car payment. So let me just go ahead and read through this. The mean monthly car payment for 121 residents of a local apartment complex is $372. What is the best point estimate for the mean monthly payment for all residents in the local complex? Well, once again, this right here is a sample mean. It's a point estimate. That's the number they're looking for. So just go ahead and write it in. And then you're done. Okay, moving on to problem number 2. A research company desires to know how the mean consumption of meat, or desires to know the mean consumption of wheat among the people over the age of 32. They believe that the mean consumption has a mean of 4.5 pounds, and they want to construct an 85% confidence interval with a maximum error of 0.6 pounds. Assuming a variance of 1 pound, what is the minimum number of people over the age of 32 that they must include in their sample? Round up to the next entire integer. So as you can see, for this particular problem, I forgot that I need to actually write some stuff down, so I need to change my screen. Okay, so here we are looking for the sample size. We are looking for n. And n is going to be equal to my critical value, all right, times my standard deviation, divided by my margin of error, and all of that squared. Okay, so what do we have? We have that our mean consumption is that the meat consumption is has a mean of 4.5 pounds. Notice that plays no bearing whatsoever in this computation. We know that we are looking for an 85% confidence interval. So C is equal to 85%. And if you have your table handy, you will realize that so corresponds to a critical value of 1.44. We know that our variance, not our standard deviation, our variance, which is sigma squared, is equal to 1 pound. That's kind of cool, because if my variance is 1 pound, then the square root of my variance, which is equal to my standard deviation, is also equal to 1 pound. So that works out. And we know that our maximum error, E, right here, is 0.06 pounds. So we have E, we have sigma, not sigma squared, sigma, and we have our critical value. So N is going to be equal to 1.44 times 1 divided by 0.06, and we are going to square all that. And let's see what we get. Let's go over to our calculator. 1.44, we don't need to do times 1, divided by 0.06. That's our answer. We need to square that. And that gives us an integer, 576. And there you go. One of the very few times where you don't need to round up to the next higher integer. Okay, moving on. Here, a toy manufacturer wants to know how many toys children buy each year. A sample of 292 children was taken to study their purchasing habits. Construct an 80% confidence interval for the mean number of toys purchased each year if the sample mean was found to be 5.6. Assume the population standard deviation is 1.8. So we know that n is 292. Okay, we know that C is going to be 80% or 0.8. And we know that our standard deviation is 1.8. And we know that our sample mean is equal to 5.6. And I should mention that is the population standard deviation. So to do this using our calculator, you just go to Stat. We want to go over the tests. We are doing a Z interval, so we can just go click down there. We're using statistics. Enter. Okay, fine. Go down. Population standard deviation is 1.5. Sample mean is 5.6. Number of samples is 292. Confidence interval is 80%, 0.8. And then we can calculate. And we have my lower limit is going to be 5.48. My upper limit is 5.71. Since my standard deviation has 1 decimal, we want to round to that. So this is going to round to 5.5. This will stay at 5.7. So notice here, my sample mean is 5.6. We go a tenth down. We go a tenth up. That's our confidence interval. So my lower endpoint, 5.5. Upper endpoint, 5.7. There you go. You're done. All right, moving on to question 4. We're more than halfway done. A market surveyor wishes to know how many energy drinks teenagers drink each week. Probably too much. They want to construct an 85% confidence interval. So C is going to be 0.85 for the mean, and they are assuming the population standard deviation for the number of energy drinks consumed each week is 1.2. So sigma is 1.2. They studied 830 teenagers, so that n is 830. And they found a sample mean of 7.3. Okay, so there we go. Stat, test, Z interval, sigma 1.2, sample mean 7.3, number of samples 830, and confidence interval 0.85. Calculate. And we have a lower limit of 7.24, an upper limit of 7.36. We only need to go to 1 decimal place, so this will round to 7.2. This will round to 7.4. That's what goes here. Okay. Question number 5. An educational psychologist wishes to know the mean number of words a third grader can read per minute. She wants to ensure that the estimate has an error of at most 0.91 words per minute. A previous study found that the mean was 40.5 words per minute. Assuming a standard deviation of 7.43, what is the minimum number of third graders that must be included in the sample to construct an 80% confidence interval? We are looking for the number of samples. That means we have to use this equation right here. N is equal to your critical factor times your standard deviation divided by your error, all of that squared. Okay, so the mean plays no role. Okay, so this doesn't matter. Standard deviation, however, does matter. That's going to be 0.19. Oh, no, that's our error. I'm sorry. That is our error. She wants to ensure that the error has an estimate of at most 0.19, so that's our error. The standard deviation is 4.3. And our confidence interval is 80%, or 0.8, which corresponds to a critical value of 1.28. Okay, so N is going to be equal to 1.28 times 4.3 divided by 0.19, and all of this is going to be squared. Okay, so let's go ahead and knock that out. Over here, clear. Well, there we go. Clear. 1.28 times 4.3 divided by 0.19. Square it. And I get 839.16. That is going to round to 840. Remember, the next higher integer. And there you go. Okay, only 2 questions left. Here, we want to estimate the mean capital income in thousands of dollars for a major city in California. Suppose that the mean income is found to be $71.2 for a random sample, in thousands of dollars, thank God, of 2,606 people. Assuming a population standard deviation is known to be $11.2, construct a 99% confidence interval. So what do we know here? We know that the sample mean is 17.2. We don't need to add the extra zeros, so it's going to be 17.2. We know that we sampled 2,606 people. Okay. This population standard deviation is $11.2 thousand, and C is equal to 99% or 0.99. Going into stat, over to tests, 7, and go make sure we're in stats. Go ahead. Sigma is 11.2. Sample mean is 17.2. Number of samples is 2606. Level of confidence is 0.99. 11.2, 17.2, 2606. And that gives us a lower limit of 16.63 and an upper limit of 17.76. Okay, our standard deviation is 1 decimal place, so this will round to 16.6, and this will round to 17.8. And then that brings us to our last question, which is basically the same type of question. Here, the Waterworks Commission needs to know the mean household usage of water by the residents in a small town in gallons per day. We're going to assume that the population standard deviation is 2.2 gallons. Sigma is equal to 2.2. The mean water usage per family was found to be 15.8 gallons for a sample of 669 families. So X bar is equal to 15.8. N is equal to 669. And we want to construct a 90% confidence interval. Okay, so C is 0.9. Here we go. Stat. Tests. 7. 2.2 for standard deviation. 15.8 for sample mean. 669 for number of samples. 0.9. And we get a lower limit of 15.66, an upper limit of 15.94. Lower limit rounds to 15.7. The upper limit stays at 15.9. That is our answer. 15.7 here and 15.9. There you go. And that wraps up everything that you need to figure out section 8.1. And once again, if you have any questions, please feel free to contact me, and stay tuned for section 8.2 when we're going to talk about another type of distribution that is used for smaller samples. The fun thing about that was that it was arranged by a guy that works at a brewing company in Italy. You'll never guess which one it is. Until then, this is Bob Boyle, signing off.